Amazon EC2 instances are virtualized servers running in AWS data centers. EC2 provides you with complete control of your computing resources and reduces the time required to obtain and boot new server instances to minutes. You can programmatically scale your computing capacity as your requirements change. You pay only for the compute capacity that you actually use. EC2 provides the tools for you to build failure-resilient applications and isolate the applications from common failure scenarios. You can leverage the AWS global infrastructure to deploy across regions and availability zones for reliability. When creating or launching an EC2 instance, decide which region you want to have that instance in. Amazon Machine Images, or AMIs, are templates from which new instances are created and come pre-installed with various AWS API tools which enable, for example, scripting of important provisioning tasks from within an Amazon EC2 instance. All Amazon EC2 instances are assigned a private IP address, and you can choose to also have a public IP address assigned to each EC2 instance. Launching EC2 instances from AMIs results in very fast first boot times. An AMI is a template that contains a software configuration such as an operating system, application server, and applications. You use an AMI to launch an instance, which is the copy of the AMI running as a virtual server on a host computer in Amazon's data center. You can launch as many instances as you want from an AMI, and you can also launch instances from as many AMIs as you need. You can create your own AMI by customizing the instance that you launch from a public AMI and then saving the configuration as a custom AMI for your own use. You can also buy, share, and sell AMIs. You select an AMI based on region, operating system, architecture, launch permissions, and storage requirements for the root volume. Multiple instances of different types can be launched from a single AMI. The instance type determines the hardware of the host computer used for your instance and the virtual hardware that is assigned to the instance. Each instance type offers different compute and memory capabilities. Therefore, you should select an instance type based on the amount of memory and compute resource needed for the application or software that you plan to run on the instance. After initial launch, your instance keeps running until you stop or terminate it. Instances are deployed in an Amazon Virtual Private Cloud in an availability zone within a region. We will cover VPCs in more detail shortly. You can deploy EC2 instances to multiple availability zones within a region. You choose which instance types you want, and then start, terminate, and monitor as many instances as needed, using either the web service APIs or the variety of management tools provided. Amazon EC2 instances can utilize Amazon Elastic Block Store for persistent block-level storage volumes. These EBS volumes must be placed in the same AZ as the EC2 instance that you wish to attach them to. EBS volumes can be saved using snapshots, and additionally, Amazon S3 storage can be used to store data objects needed by your Amazon EC2 instances. With all of these services shown here, customers pay only for the resources that you actually consume or provision, such as instance hours or data transfer. An Amazon EC2 instance can be in one of the following states. Pending. When you first create or launch an instance, or when you start a stopped instance, it enters the pending state. If the instance already exists and was stopped, it is now moved to a new host computer. The instance type specified at launch determines the hardware of the host computer for your instance. The running state. After the pending state, the instance enters the running state. You can connect to your running instance. When your instance is in the running state, you're billed for each hour or partial hour that you keep the instance running. You are billed for all running instances, even if they are idle and not being connected to. The rebooting state. You can reboot your instance through the Amazon EC2 console, the EC2 CLI, and the Amazon EC2 API. It is recommended that you reboot your EC2 instance instead of running the operating system reboot from the instance. When an instance is rebooted, it remains on the same host computer and maintains its public DNS name, private IP address, and any data on its instance store volumes. Rebooting an instance doesn't start a new instance billing hour. Shutting down. You will stop incurring charges as soon as an instance enters shutting down or terminated states. An EC2 instance in the shutdown state can be started again if required. Terminated. When you no longer require an instance, you can terminate it. A terminated instance remains visible in the management console for a while before it is deleted. You cannot connect to or recover a terminated instance. As with stopped instances, you will not incur charges for terminated instances. Unlike stopped instances, however, an EC2 instance in the terminated state cannot be started again, as terminating an instance deletes that instance from your inventory of EC2 instances. Stopping. Amazon EBS-backed instances can be stopped. When you stop an instance, it enters the stopping state. Stopped. Amazon EBS-backed instances in the stopped state are no longer eligible for hourly usage or data transfer fees. AWS does charge for the provisioned storage space of EBS volumes on stopped instances. You can modify certain attributes of stopped instances, including the instance type. Starting a stopped instance puts it back into the pending state, which moves the instance to a new host machine. When you stop and start an instance, you lose any data on the instance store volumes on the previous host computer. When launching new EC2 instances, the AWS Marketplace provides you with the opportunity to create your new instance with commercial off-the-shelf software that is automatically installed on your instance, offers charging with the pay-as-you-go model as with Amazon EC2, and centralized billing as charges are included in your monthly AWS bill. The AWS Marketplace currently offers over 4,000 separate software titles from over 1,100 independent software vendors. Choosing the right EC2 instance type is important. We have a wide variety of EC2 compute instance types for you to select from. These run on Intel Xeon processors, which are compatible with the broadest range of ecosystem software and offer high performance and reliability. Each instance type or family is optimized for different workloads or use cases. Within each type or family, we have multiple sizes, for example, large, extra large, 2XL, etc. When you choose your instance type, you should consider the different attributes of each family, such as number of cores, amount of memory, amount and type of storage, network performance, and Intel processor technologies. AWS recently launched C4 compute-optimized instances which utilize Intel's latest 22nm Haswell microarchitecture. C4 instances use custom Intel Xeon V3 processors designed and built especially for AWS. Through its relationship with Intel, AWS provides its customers with the latest and greatest Intel Xeon processors that help in delivering the highest level of processor performance in Amazon EC2. Intel Xeon processors have several other important technology features that can be leveraged by EC2 instances. Intel AVX is perfect for highly parallel, high-performance computing workloads such as life sciences or financial analysis. Intel AES-NI accelerates encryption-decryption of data and therefore reduces the performance penalty that usually comes with encryption. Intel Turbo Boost technology automatically gives you more computing power when your workloads are not fully utilizing all CPU cores. Think of it as automatic overclocking when you have thermal headroom. Our X1 instance types offer very large amounts of both CPU and memory and are optimized for large-scale enterprise-class in-memory applications. X1 instances are recommended for running in-memory databases such as SAP HANA, big data processing engines like Apache Spark or Presto, and high-performance computing applications. The table in this slide details the associated Intel technologies and storage information for each instance family. Yes, there is a lot of detail in this table. Amazon EC2 lets you choose from several different instance families to meet your computing needs. Each instance provides a predictable amount of dedicated compute capacity and is charged per instance hour consumed. Compute-optimized instances have proportionally more CPU resources than memory and are well suited for compute-intensive applications, whereas memory-optimized instances offer large memory sizes and are well suited for memory-intensive applications. There are also various high storage, GPU-equipped, and very large memory instance types available. EC2 instance metadata is data about your instance and is divided into multiple categories. This metadata can be queried and can be used, for example, to decide how to configure or manage any running EC2 instance. Instance metadata is available from your running instance, thus you do not need to use the Amazon EC2 console or the AWS command line interface to access instance metadata. This can be helpful when you're writing scripts to run from your instance. Note that you are not billed for HTTP requests that are used to retrieve instance metadata or user data. Instance user data is a script that can be specified for an instance, and if so, it will be executed at an instance's first boot. This script can be used to control final specific configuration for your instances that are launched from more generic AMIs. It is important to note that instance user data is executed only at instance launch. If you stop an instance, modify the user data, and start the instance, the new user data is not executed automatically by default. This slide shows an example of user data on Linux. This shell script will install an Apache web server daemon, set it to auto start for each subsequent boot of the instance, and finally start the service for this boot of the instance. For your Microsoft Windows Server instances, you can send user data via a PowerShell script, as shown in the slide, or with a set of Windows batch commands. This enables you to fully configure your Windows Server instances at first boot, most typically via PowerShell. To determine the user data that was executed when an instance was launched, use the EC2 Management Console, or from within the instance, you can use the URI 169.254.169.254/latest/user-data. AWS provides a number of different payment options for the Amazon EC2 service, and thus you're running EC2 instances. Let's examine these options. On-demand instances are free tier eligible. The AWS free tier is a collection of our services that you can use and learn with for your first 12 months for free. Certain capacity and usage limits do apply. On-demand EC2 pricing has no upfront costs, no long-term contracts, and the most flexibility. You pay by the hour or part thereof for your running instances, and no hourly charges apply for stopped or terminated instances. This is great for applications with short-term, spiky, or unpredictable workloads. Amazon EC2 reserved instance pricing allows you to reserve computing capacity for 1 year or 3-year terms at a significantly discounted hourly rate. Reserved instances providing a billing discount and a capacity reservation that is applied to instances to lower your hourly running costs. A reserved instance is not a specific EC2 instance. It is actually a reservation and pricing contract that can float across various EC2 instances of the same type in the same availability zone and region. If you are expecting consistent, heavy use, reserved instances can provide substantial cost savings over owning your own hardware or running only on-demand instances. Scheduled reserved instances enable you to purchase capacity reservations that recur on a daily, weekly, or monthly basis with a specified duration for a 1-year term. You reserve the capacity in advance so that you know it is available when you need it. You pay for the time the instances are scheduled, even if you do not use them. Scheduled instances are a good choice for workloads that do not run continuously, but do run on a regular schedule and take a finite time to complete. Spot instances enable you to bid on unused Amazon EC2 instance capacity, which can lower your Amazon EC2 costs significantly. The hourly price for a spot instance fluctuates depending on the supply of and the demand for spot instances. Spot instances run whenever your bid exceeds the current market price. Spot instances are a cost-effective choice and ideal for jobs that take a finite time to complete, such as batch processing, encoding and rendering, modeling analysis, and continuous integration. An Amazon EC2 dedicated host is a physical server with EC2 instance capacity fully dedicated to your use. Dedicated instances are physically isolated at the host hardware level from instances that belong to other AWS accounts. Dedicated hosts allow you to use your existing per socket, per core, or per virtual machine software licenses, including Microsoft Windows Server, Microsoft SQL Server, SUSE, and Linux Enterprise Server. Dedicated hosts and dedicated instances can both be used to launch Amazon EC2 instances onto physical servers that are dedicated for your use. There are no performance, security, or physical differences between dedicated instances and instances on dedicated hosts. However, dedicated hosts give you the additional visibility and control over how instances are placed on a physical server. That completes our coverage of Amazon EC2. In this networking section, we'll explore topics covering virtual private clouds, subnets, and network security. With the Amazon Virtual Private Cloud Service, you can define a virtual private network topology that closely resembles a traditional network that you might operate in your own data center. You have complete control over your virtual networking environment, and you can easily customize the network configuration for your virtual private cloud, including selection of IP address range, creation of subnets, configuration of route tables, and network gateways. Each VPC is totally network isolated from all other VPCs. This allows you to build totally separate network environments. For example, a dev and test VPC can be totally separate from a production VPC. VPCs exist within regions. That is, they cannot span across multiple regions. VPCs, however, can span across the availability zones that exist within regions. VPCs are made up of one or more subnets. Subnets exist within AZs, that is, they cannot span across multiple AZs. Just like a VPC, a subnet has a defined private IP address range. The address range for a subnet must be a logical subset of the address range assigned to its parent VPC. Subnets can be private or public. Instances that you place in a private subnet are assigned a private IP address, whereas instances placed in a public subnet have both a private and internet accessible public IP addresses. Public subnets also have a route to an internet gateway, whereas private subnets do not, thus making resources placed within them inaccessible from the internet. Note though that all instances within a specific VPC can communicate with each other via their assigned private IP address and a managed routing service that AWS operates for you between the subnets of your VPC. Shown here in the slide are some examples of VPC usage. For example, you can create a public-facing subnet for your web servers that require access to the internet and place your back-end systems, such as databases or application servers, in a private-facing subnet with no internet access. Additionally, you can create a virtual private network, or VPN, connection between your corporate data center and your VPC, which allows you to leverage the AWS cloud as an extension of your corporate data center. You can leverage multiple layers of security, including security groups and network access control lists, to help control access to your resources in each subnet. Security groups act as a firewall for associated instances, controlling both inbound and outbound traffic at the instance level. Network access control lists act as a firewall for associated subnets, controlling both inbound and outbound traffic at the subnet level. Amazon EC2 uses public key cryptography to encrypt and decrypt login information. Public key cryptography uses a public key to encrypt a piece of data, and the recipient uses the private key to decrypt the data. The private and public keys are known as a key pair. To log into your EC2 instance, you must create a key pair, specify the name of the key pair when you launch the instance, and provide the private key when you connect to the instance. Linux instances have no password, and you use a key pair to log in using SSH. Windows instances require a key pair to obtain the administrator password to log in using RDP. Now that we have explored the features of Amazon EC2 and VPC, let's take a look at the EC2 Management Console. Please note that, as is the case with other AWS products and services, Amazon EC2 is also accessible through a command line interface and via the EC2 API for developers. You can see here that I am signed in to the AWS Management Console, which we demonstrated earlier. In the menu, you can see both who you signed in as and which AWS account you have accessed. I'll demonstrate launching an Amazon EC2 web server instance. So first, I'll access the EC2 console. Then we launch an instance via the EC2 wizard. I'll select an Amazon Linux operating system. Other Linux and Windows Server options are available though. The default instance type is T2.micro, which is suitable for this demo. 1 vCPU and 1 gig of memory. In instance details, I'll place the instance in the default VPC that is provided for all customers. This is a great choice for quick demos or non-critical instances. I will place the instance in SID AZA, but B or C are equally appropriate choices. Importantly, for this demo, I want to ensure that the instance is publicly reachable, hence I have selected Enable for Auto Assign Public IP. Next, in Advanced Details, I will paste some shell script code. This script will execute when the instance first boots, and it will install an Apache web server daemon, set the web service to auto start for future boots, start at the first boot, and install various HTML resources to present a web page. Our Linux web server will have 8 GB of storage, which is sufficient for this demonstration. However, more can be configured if required, either now or later. Let's give the instance a tag of name equals web server for easy identification in the management console. And here I will create a new security group that will allow only HTTP traffic on TCP port 80 to reach the instance. All other traffic attempting to access this instance will be blocked. Next, a review of settings configured so far is displayed. And finally, I will choose Proceed without a key pair, as I will not need to remote control this instance using SSH. I will only need to browse to it using HTTP. Next, we launch the instance. Whilst the instance is launching, check the instance details, observe its private IP address, refresh the screen, and in a short while, you'll also see the public IP address displayed. We can now use either the public IP address or the instance's public DNS name to browse to our web server. In this case, our web page has been constructed to display various metadata about the instance itself. In 1 minute from clicking Launch Instance, we now have a running web server running on Amazon EC2. That completes this demonstration of Amazon EC2. I hope you found our coverage of core compute and network infrastructure services valuable. Let's now take a look at some of the AWS storage services. In this section, we will introduce you to 2 key AWS storage services: the Amazon Simple Storage Service, or Amazon S3 as it is known, and Amazon Elastic Block Store, or Amazon EBS. Amazon S3 provides a simple web services interface that can be used to store and retrieve any amount of data at any time from anywhere on the web. It gives any AWS customer access to the same highly scalable, reliable, secure, fast, inexpensive infrastructure that Amazon uses to run its own global network of web applications. There are no limits to the space you consume in S3, and there is no limit to the number of objects you store in S3. There is, however, a soft limit of 100 buckets per AWS account. A soft limit is a limit that can be raised upon request if required. A bucket is the name of a top-level container that you create in S3 to store objects within. The maximum size of a single object that can be stored in S3 is 5 terabytes. Amazon S3 is designed for 11 nines of durability and 99.99% availability of objects over a given year. You can use HTTP or HTTPS endpoints to store and retrieve any amount of data at any time from anywhere on the web. Importantly, Amazon S3 is highly scalable, reliable, fast, and inexpensive. Some very common use cases for S3 include providing storage for logs, backups, images, documents, AMIs, EBS snapshots, whereas some more advanced use cases include using S3 to store web page assets and to deliver a static website directly from S3. Amazon S3 stores data as objects within buckets. An object is composed of a file and any metadata that describes that file. To store an object in Amazon S3, you upload the file you want to store into a bucket. When you upload a file, you can set permissions on the object and add any metadata. For each bucket, you can control access. In other words, who can create, delete, and list objects in the bucket. You can also view access logs for the bucket and its objects, and choose the geographical region where Amazon S3 will store the bucket and its contents. The combination of a bucket, key, and optionally a version ID uniquely identifies each object stored in S3. In this example, doc is the name of the bucket, and 2006-03-01/AmazonS3.html is the object key. It is important to note that bucket names must be globally unique across all AWS regions and accounts. With Amazon S3, you have total control of who has what access to each object you store in S3. Encryption of data in transit to and from S3 is possible via the SSL encrypted endpoints for the S3 service. The encrypted endpoints are accessible both from the internet and from within AWS, so that data can be transferred securely both within AWS and to and from sources outside of AWS. Encryption of data at rest within S3 is available via a number of methods, and at no extra cost to storing data unencrypted. Customers who prefer to manage their own encryption keys can encrypt data before uploading to Amazon S3. Alternatively, you can use Amazon S3 server-side encryption if you prefer to have Amazon S3 manage encryption keys for you. With Amazon S3 server-side encryption, encryption happens automatically when data is written to S3, and decryption happens automatically when data is retrieved. Versioning is an S3 feature for keeping multiple variants of an object in the same bucket. You can use versioning to preserve, retrieve, and restore every version of every object stored in your Amazon S3 bucket. Lifecycle management defines how Amazon S3 manages objects during their lifetime. Some objects that you store in an S3 bucket might have a well-defined lifecycle. For example, if you are uploading periodic logs to your bucket, your application might need these logs for a week or a month after creation, and after that you might want to delete them. Some documents are frequently accessed for a limited period of time. After that, you might not need real-time access to these objects, but you might need to archive them for a longer period and then optionally delete them. Financial and healthcare records, long-term database backups, and data that must be retained for regulatory compliance are some of the kinds of objects that you might upload to Amazon S3 primarily for archival purposes. When you configure a lifecycle rule, you specify the storage class you want to transition the object to and the number of days after object creation when you want the transition to occur. You can transition objects to the S3 infrequent access storage class, archive them to Amazon Glacier, or have them permanently deleted. S3 infrequent access is useful for data such as backups and other older infrequently accessed data where high performance continues to be a requirement. Pricing for Amazon S3 is made up of consumed storage pricing and request and data transfer pricing, with storage pricing for the APAC regions currently at a prorated 2.5 US cents per gigabyte per month. With Amazon S3, you pay only for what you use. Amazon Glacier is a data archival storage service. In the AWS Asia Pacific regions, it is currently priced at 0.5 US cents per gigabyte per month, offering extremely low cost archival storage for files requiring long-term retention. Using S3 lifecycle policies, you can easily have objects automatically transitioned to Glacier storage from S3 storage. When you have the opportunity, I recommend you investigate two new exciting AWS services that work together with Amazon S3. They are Amazon Athena and Amazon Macie, spelt M-A-C-I-E. The table displayed here details 3 storage classes that are available for S3 objects. Every object in Amazon S3 has a storage class associated with it. S3 Standard is the default storage class in S3 and is ideal for performance-sensitive use cases and frequently used data. S3 Infrequent Access is optimized for long-lived and less frequently accessed data, such as backups, and older data that is accessed infrequently but still requires high performance. Glacier is suitable for archiving data where access is infrequent and a retrieval time of several hours is acceptable. Archived objects are not available for real-time access. They must be restored before they can be accessed. Glacier storage is, however, very low cost. Now let's take a look at Amazon EBS. Amazon Elastic Block Store, also known as Amazon EBS, provides persistent, block-level storage volumes for use with Amazon EC2 instances and offers consistent and low-latency performance. EBS is particularly suited for applications that require a database, file system, or access to raw block-level storage. Snapshots taken of EBS volumes are durably stored and replicated in Amazon S3 in the same region as used for the EBS volume. For even greater durability, if required, these snapshots can be replicated to another region of your choice. EBS volumes can be attached to any instance in the same availability zone as the volume. Volumes attached to an EC2 instance are exposed as storage volumes that persist independently from the life of the instance. When EBS volumes are not attached to an EC2 instance, you pay only for the cost of storage based on provisioned size. Amazon EBS provides various volume types, which differ in performance characteristics and price, so that you can tailor your storage performance and cost to the needs of your applications. The volume types fall into 2 categories: solid-state drive-backed and magnetic hard disk drive-backed volumes. This table displays the characteristics of the different EBS volume types that are available for you to select when creating new EBS volumes. You can attach multiple EBS volumes to the same EC2 instance, but each volume can be attached to only one EC2 instance at a point in time. EBS volumes behave like raw, unformatted block devices. You can create a file system on top of these volumes or use them in any other way you would use a block device like a hard drive. Amazon EBS is particularly helpful for database-style applications that frequently encounter many random reads and writes across the dataset. You should think of an EBS volume as simply a virtual hard drive. So a great use case for Amazon EBS is when you want the hard drive to persist past the life of the Amazon EC2 instance. EBS volumes are ideal for root volumes for your instance operating system, for database storage, and datasets that are up to 16 terabytes in size. Please note that Amazon EBS pricing is based on allocated storage. This is unlike Amazon S3, where pricing is based on space actually consumed. Additional charges apply for EBS with provisioned IOPS. Amazon EBS volumes are designed to be highly available and reliable. EBS volume data is replicated across duplicate storage systems within a single availability zone that you select when you create an EBS volume. This replication prevents the loss of data from the failure of any single component. Because EBS volumes are replicated within a single availability zone, establishing mirroring of data across multiple EBS volumes from within your EC2 instance's operating system will not significantly improve volume durability and is therefore not required. EBS volumes must be in the same availability zone as an instance to enable attachment. You can create point-in-time consistent snapshots of your EBS volumes to establish even greater durability than what is provided by a single AZ. EBS snapshots are stored in Amazon S3 and automatically replicated across multiple availability zones within a region. If required, you can even replicate these snapshots to other AWS regions for even greater levels of durability. The table in this slide illustrates the significant differences between Amazon S3 and Amazon EBS. EBS volumes are network-attached hard drives that can be written to or read from at a block level. Amazon S3 is an internet-accessible, object-level storage service. This means that you must write whole objects to S3 at a time. If you change one small part of a file, you must still rewrite the entire file in order to commit the change to Amazon S3. This can be time-consuming if you have frequent writes to the same object. S3 is optimized for write once, read many use cases. The other major difference is cost. With Amazon S3, you pay for what you use, and with Amazon EBS, you pay for what you provision. EC2 Instance Storage provides temporary block-level storage for your EC2 instances. This storage is located on disks that are physically attached to the host computer running your EC2 instance. Instance Store is ideal for temporary storage of information that changes frequently, such as page files, buffers, caches, scratch data, and other temporary content, or for data that is replicated across a fleet of instances, such as a load-balanced pool of web servers. Instance storage is very fast, it is free, but its contents do not persist if you stop and then later start an EC2 instance. The use case for local instance store is for temporary data only. For data that requires a higher level of durability, use Amazon EBS volumes or back up the data to Amazon S3. Finally, the table in this slide shows key differences between rebooting, stopping, and terminating your instance, including data persistence for Instance Store and EBS volumes. Awesome. In this second module, you learned about the key infrastructure services offered by AWS, including compute, network, and storage services.